What is happening? Mark Bare Naked Willie, how are you, my friend?
2-year anniversary, Dave Cooper Live.
2 years straight. We have been doing this show every Friday for 2 straight years. I don't believe we missed a single Friday, to include holidays. Have we, Mark?
We haven't missed a single one. There's been 2 times I had problems getting on the show, and it's been phenomenal. So happy to be here today and to have this topic on a BS Friday Live.
Ooh, we're going to talk about carbon beam calculator. Today's going to be a great day. Welcome, everybody. We are live on LinkedIn, YouTube, Facebook, Twitch, and Twitter. So get your tweets on and make sure you subscribe to our YouTube channel. Mark, you're not going to believe it, man. We're hitting hundreds of thousands of hours or minutes and hours watched every month on our YouTube channel. It is going through the roof at the moment. So we're super excited about that. So if you are not subscribed, I highly suggest you go there and subscribe. We'd love to see you on YouTube. And I want to put it out there real early, Mark. We got a pretty cool show. I don't even know if I told you it's 100% locked in next Friday. Next Friday, we have Shemaine Nugent. Shemaine Nugent, that's right. The Motor City Madman's wife, Ted Nugent. She's going to be on the show talking about her new book and documentary, Killer House. They almost died of black mold in their house, Mark. We're going to have them on the show because she's on a mission to educate people how to look for and understand how your house can be making you sick. So it fits right in with BS Friday.
Absolutely. And the more books and the more exposure get out like that, that's our goal, right? To bring health to every shelter, church, schools, you name it. You don't know what's lurking in those walls and behind those dressers and behind those cabinets. So check it out next Friday.
Yeah, next Friday, Shemaine Nugent. It's going to be great. It's going to be great. But until we get to next Friday, we have something even better. The first, the one, the only. What is it, Mark?
Well, it's a launch, right? It's a launch to something that's not a stranger. No, he is not a stranger to this community, right?
Nope.
And when you create something, a tool for our buildings, it is each of our jobs to expose it, to bring it to our associations and community. Bring them out here, Dave. Let's get going.
Yeah, enough BSing around. What's happening, Chris?
Hey, nice to be here with you guys.
Dude, it is always awesome to see you come back on the show. I was just teasing Mark earlier, everybody, that I'm just hoping Chris doesn't make Mark look bad because Chris is one smart dude. Mark's pretty smart, but Chris is one smart dude. So,
the interesting thing about Chris is the tool he has makes us all better at what we do. Chris, in fact, Chris is making us all better from the buildings to our lives. And
100%. Chris, why don't so you were on the show a few months back. I mean, it's been a while now. Why don't you just give us a quick rundown of what you're up to these days, where we're headed, and then we're going to get into this new free calculator that you have created, and we're going to talk about when it was launched or did it launch. So let's go, Chris. Go ahead. You got 2 minutes.
Sure. Well, 2 minutes. Basically, the small team of us at Builders for Climate Action has been doing a bunch of things. We did 3 really interesting studies of the carbon footprint of residential scale buildings. So maybe we'll touch on some of those results and what came out of those studies. But the sort of most recent news and the thing that's I'm really excited about is that our Beam estimator tool went live back on May 3rd. So it's been out 10 days now. Last time I looked, we were pushing 400 people using it already. So that's great. But this is a tool that we've been developing and using in-house for a couple years now, and it's now available for anybody to use. And it's a really great way to be able to figure out the carbon footprint of the materials that you're putting in your building. We tried to make it, accessible and easy to use, and I think we did a great job.
So, Chris, I just there's a lot of people that are now tuning in that just are trying to learn about building science. maybe don't understand the value of what you've created. What is the carbon footprint? Maybe just give us the overview of why people really should be paying attention to it, and then let's get into the value of what you actually created.
Sure. Yeah. So, what Beam does is give you a look at what the carbon footprint of the materials are for your building. And the reason you might care about that is because, especially people who've been involved in making buildings more energy efficient, part of the reason that we're doing that is for the climate. If you can make the building more efficient, if you can electrify it, if you can do all the good stuff that we've been doing in that way, making the building more airtight, all that kind of stuff reduces the impact on the climate. But one thing that we started realizing in our own practice about 10 years ago was we're doing all of that, and yet we have no idea what the carbon footprint of the material part that we're using to assemble the house was. So this all started with me just trying to do a back of the envelope, what's the carbon footprint of the buildings that I'm involved in making. And quite frankly, the numbers are a bit stunning. And what we've learned since is that it's not unusual for a house in North America to have 500 kilograms. That's half a ton of emissions per square meter of floor area. And It's like you can be doing all kinds of great stuff to make your building operate really cleanly, but if your building has like 80 tons of emissions involved in just making the materials in the first place, like suddenly that's the big piece. And if we're going to try to get the climate thing under control, we can't ignore that. That all that stuff goes into the atmosphere before somebody moves into that building. And so the sort of path I've been on is how do I figure this out really well? How do I know I'm getting the right numbers? And then once I felt like that was happening, it's like, now how do I share this with as many people as possible? And so, the Beam tool is something we've been using internally and developing internally, and we finally decided, it's ready to go out into the world and be a big grown up tool and be out there all on its own.
I love it.
Chris, can we start with the foundation of what is embodied carbon, what is operational carbon?
Absolutely, yeah. So embodied carbon is the emissions that happen from making things. And here we're talking about building materials and products, but we could be talking cars or food or anything. But so if I'm gonna pour a concrete foundation, a whole bunch of things need to happen that all cause emissions. Somebody's got to go, harvest that limestone. Somebody's got to crush it. Then they've got to burn it. Then they've got to, there's all this stuff happens before it arrives on the site, and
including the transportation.
And so it turns out if you add all that up, it's big. And if you add it up for, everything that goes into a building, and, buildings are the thing where almost all the stuff on the planet goes. Like, buildings represents the vast majority of the sort of material flows on the planet. And if all of those materials have a carbon footprint associated with them, we need to understand that, or, we're just going to keep causing those emissions to happen and kind of blindly, like, oh, that happens over there. I don't see it. I don't hear about it. I don't smell it. I don't, it just happens. And so, that's what I've been trying to do, is figure out, well, what is that, and how do we count that? How do we know what that is? And now how do we sort of share it and calculate it? So, So, and that's different from the operational side. The operational side is, okay, now this building exists. I heat it, I cool it, I turn lights on and off. I do all of that stuff, and the energy that's used to power that building has various amounts of emissions associated with it, whether I'm burning oil or gas or using electricity. So, those emissions we've understood for a long time. And it's the material side that we've been trying to shed some light on. And it becomes really important because, as builders, there's certain things we can do to reduce that carbon footprint of the operations. Like, we can make better buildings, they can be more airtight, they can be better insulated, but also, we can't affect the grid in our location, or like the sources of energy, but collectively we're like on the path to driving all of that down. So But if you look at, say, the next 10 years, which is what we kind of have to deal with the climate, 10 years of operating emissions from any building don't add up to all that much. But that first burst of emissions from all the materials does add up to a lot. And so we can't subtract those from the atmosphere later. We can't make the embodied carbon of a building lower in the future. Like, those emissions went into the sky, there they are. We can't, get rid of that. So we have to think about it before we make the building. And so, yeah, that's what we're hoping Beam does, is just make that really clear to people. Like, these choices I'm making, this is the impact of them. And, oh, look, there's other choices that have either higher or lower impacts, and really just trying to get people to, see where they can make the difference. And I think one of the first things that people really notice when they start working with a tool like Beam is like, holy crap, there's a lot of low-hanging fruit here. Like, if I thought this was going to be a slog, there's a slog at some point, but right off the bat, when people start scrolling through the tool, they're like, seriously? Like, if I choose this over this, I save that much carbon footprint. So
the amount of data
gives you the power of choice.
Yeah.
Well, I was even looking at the amount of data, Mark, think of the work to be able to create those choices, the amount of time and energy, Chris, and sleepless nights that you probably went through trying to pull all this together to give people, because it's easy to say no, but it's not easy to say, well, here's some alternatives that will be better for you. And it sounds to me like you've created both of these things. And we all know in our built environment, when it comes to building materials and supplies, there's a lot of options out there. So, that's impressive.
Yeah, it's building software is more work than building a house. That's one thing that I learned.
How supportive is the industry, right? Because there's information that is probably needed, right? And perhaps the contacts on the other end of the ship, they might not know that information on the ready, right? Somewhere in their silo it would be. But how does that flow? Do you find open gates from the various manufacturers?
Yeah, it's varied. So everything in Beam, all the calculations in Beam are based on these things called environmental product declarations, which are like it's an ISO standardized way of taking a life cycle assessment of a material and reporting on it, so that we know we're more or less reporting the same types of emissions calculated in the same way for comparable materials. So I kind of liken them to both. An environmental product declaration is sort of like the food label, where it's and so it gives you a whole bunch of information about environmental impacts of a product. And same, if you're really concerned about, say, your fats or your carbohydrates on the nutrition label, in an environmental product declaration, we're looking at the global warming potential, or that sort of like the climate impact of that material. And so, in the same way that, like, if I, take a spoonful of my Cheerios in the morning, that nutrition label tells me that, oh, you just had 10 grams of fat. Well, honestly, it might be 10.2, or it might be like 8.6 or something like that. But they used a methodology to figure that out. And that allows me to compare my Cheerios to my Shreddies or something. And so the environmental product declarations are the same for building materials. Like, I can't, I'm not going to compare a concrete slab floor to a window glass, because like they're not the same thing. They both have a carbon footprint, but it's, I'm not going to make a choice between windows or concrete, but I can look at different concrete mixes, or I could look at an alternative to concrete, or, in the insulation category or the cladding category. Like, then you're sort of getting into those apples to apples comparisons. And the tool is as complete as it can be today. Like, not every product has an EPD. We felt it was ready to go out in public because at least every category of material has some representation in there now. Some categories have a lot, and some it gets right down into specific products, and some are still at the level of like the whole industry did one EPD that represents every manufacturer. So you kind of have this like general number. But you can accurately find everything that you would want to make a house out of in the tool now, and there's some degree of EPD out there to represent it, and hopefully it'll grow longer.
But why don't we show this tool? Let's show it. Let's put it up. What do you think, Mark? Can we show it?
I think there's probably people out there Googling it as we speak that haven't heard about it. So welcome, welcome to Beam.
That's it. I mean, I absolutely love this. So if you're looking for this, I know Jen's putting a link, but it's buildersforclimateaction.org. And right across the top, as you can see, it says Beam Estimator. Just click on that, and that's going to bring you right here to this awesome screen. And this is where everybody gets started. Why don't you just kind of walk us through the basics of this, and then we'll get back into the science.
Sure. Yeah. I mean, on the website, this is where you sort of access the tool. So it's kind of like here's why you would want to bother using this tool. And there's a bit about our methodology. There's a bit about our sponsors. We had a lot of people beta test it. So, you can see what kind of testimonials there are. And, I think in general, people, the people who beta tested it, really liked it. Lots of great comments. And yeah, some sort of salient points. We tried to make it as easy to use as possible. I'm not a software person. I'm a builder, and so in being involved in making this software, goal number one was like, I have to be able to figure it out, which is a pretty low bar. But I think that it turned out to be really good because, it does, it had to be something I could figure out. And if I can figure it out, anybody can figure it out. So it is easy to use.
That's really a godsend too, though, because you come from this world, right? And so you're able to see the flow. So now this industry can't turn around and say, well, this is another software. Like, we don't use softwares. Well, look at Chris's background. He's living proof of why this exists. And now it's just automatic, if you will, that you must have this.
And I see this as a great selling tool for builders with their customers. I mean, this just shows you're thinking at a different level. So if you're a developer, you're a builder, and you're out there, to me, this isn't something to cause you more work. This is another reason why somebody should do business with you. That's how I look at this tool. This separates you from the pack.
If a project team comes to you, right, and they show you your project and this format and these options and the weight and the gravity of all your choices, and the next day someone comes to you with a 4-page paper printout document of a bid, I think the conversation is with group one, and group two is sit there with scratch paper in their hands.
Yeah, I agree.
Yeah. And so, it works like a lot of building softwares, up front, you have all your project ID stuff that you put in. We tried to make it's based on building dimensions. We tried to make as few inputs as possible. And then kind of the what's going on in the background is two things. The dimensions you give us turn into material takeoffs. So, you tell us you've got, 900 square feet of foundation wall that's 8 inches thick, and we can calculate how much concrete and rebar and, all of that stuff is in there. And then we have these, global warming factors from all these EPDs. And so it's like this much material times this GWP is the answer you see in Beam. And I think, it all started with me trying to figure this out for myself. And what I really wanted out of the tool was really easy comparisons. And what I found frustrating with some of the tools I tried to use was I actually had to build a whole model and choose like all the materials for the model and get to an answer at the end. But like really what I wanted to see was like, well, in the insulation category, like what are my choices? And so in Beam, it's set up that way. You build a building assembly by assembly, and you're in the exterior wall assembly, you get to cavity insulation, and there's the list of, however many insulation products there are already at, the square footage of your building and the R value that you specified. You can just scan your eye up and down the list. Like there's all the answers. And it's like, okay, that one, boom, I'll choose that one. Now I move on to my sheathing. Now I move on to my cladding. Now I move on to, but at each stage you're looking at all the options and seeing the answer for your building. And that's just proved to be really powerful, because people aren't aware how different those choices are. Like, oh my God, this thing and this thing, like this one is like 5 times higher in carbon footprint than this one. I would have otherwise assumed that those were interchangeable products, or like I use them as though, I could have this or that. But if I think about the carbon footprint now, it's like, oh, clearly this one is the option. So
yeah, there was no awareness of this before. You would have to scour each of these different things and wind up with a family of notebooks that don't cross correlate.
Yeah. Right? And the EPDs, like anybody could do this. The EPDs are publicly available, but the problem is the EPDs give you like an emissions factor per some amount of that material. So, and it's not always the same, right? It's like kilograms of emissions per cubic meter of concrete and kilograms of emissions per square foot of tile. And if I want to compare a concrete floor to a tile floor, I have to figure out, well, how many cubic meters are in this floor, and then that emission, there's just a lot of math. Yeah. And so kind of what we did was like, we'll just do all that math, so you're getting the answers in a common denominator already for, scaled to your building.
Well, sometimes we've heard things, or we get used to things as well. So this eliminates the assumption, or let's say accidental misinformation, right? Mm-hmm. Even folks that have been entrenched in this for a while, we get used to, I put the blame on myself first. This isn't a finger pointing. We get used to certain wall assembly things, and we don't think about, okay, in this region, they need to do it this way. So what I've done doesn't apply, right? It's an example, but it could be an accident too. Mm-hmm. A dangerous accident is what I'm alluding to.
I mean, Chris, you've created this tool. It's free. There's a ton of work. There's a ton of data. I got a 2-part question, right? Those that are going to benefit from this, and this is something Jennifer put in the background, so her brain works much better than mine in a lot of instances, and but how do people support this? Because this is an ongoing thing, right? As products come on the market, products change, data comes in, data goes out. People give you feedback, right? Because you're probably getting feedback from using the tool or finding little glitches. Things happen, right? So how are all of the people that are watching this going to be able to not only use this and benefit from it, but also support you? What are you looking for to get the support to keep this going? Because like you said, you're a builder, and most builders I know are busy building.
Yeah, I think, we made a decision that we didn't want to put the tool behind a paywall because we wanted as many people as possible to use it. But also, we're hoping that people will contribute to the tool, either as you sign up for it. There's, right away, there's an option to, contribute, you can tick boxes, $50, $100, something like that. And yeah, we're just really hoping that, people see the value of this. Like if you wanted to do a custom calculation like this for your house, you'd be into 3 months of, full-time work to figure it out for, one set of assemblies for one house. And we've made it super easy. So we're just really hoping that people sort of like see the tool, see the value of the tool, and, pretend it's paid software, but you pay what you think it brought to your practice in terms of value.
Yeah. I can't wait for the developer that works with his team for the procurement and selection and all that. And everyone involved on the team has pulled this together. They produced the model. The model showcases all this information. And then as they replicate that model again and again, now this tool is a transformational portion for their business, but also they realize that other communities haven't taken that example. And so now they pay it forward. And this, I feel, is the standard, right? So stop waiting for what's the next best thing. It's here. This is what we wanted. And Chris's experience has brought it to the table. And he says, take it, share it, and support it.
Well, and I think, if you're watching this, whether it's live or it's the recorded show after this, I would behoove you to go and take that website and just share it on your profiles, your LinkedIn, and congratulate somebody that's actually taken the first steps to make something usable for the rest of us that understand carbon but don't truly understand how to calculate, because it's very complicated. So I think that should be commended. So if you're listening to this now or later, live or not, copy that URL and share the Beam calculator around and just say, hey, give Chris a big shout out. He deserves it. I think that's absolutely brilliant. Mark, why don't we get to a couple comments here real quick and just say hi to some folks that are joining us.
And let's do it.
All right. So we already said I put a couple flashes up, but we'll say hi. Paul Barretto's out there. What's happening, Paul? Good to see you from Maryland. We got Lisa Renda. Congratulations on 2 years. Well, thank you very much. 2 years our show's been going on, so this is an anniversary for us. I know Mateo's in here as well with a question. We'll get to that in one moment, but we got Derek from Lumenkosh. Hi, guys. Derek from Lumenkosh. Excited to see the calculator. He's up late tonight, huh? He stayed awake just to see you. Chris, I mean, you gotta buy him breakfast or something, you know?
I think when Derek comes back to North America, he'll make a beeline for Chris's door and say, Greg, thank you so much. We appreciate you.
Yeah, love it. Derek also said tools are everything. I know his name's not popping up there. We got Buzz Holitzer in the house. What's happening, Buzz? Conklin, Michigan. I know. I got to get up there and do some mudding in one of his four-wheelers. That guy seems to have more fun than the rest of us.
That's one of those all-electric four-wheelers, right, Dave?
Oh, yeah, I'm sure it is. Yep. Just go with it, Buzz. Happy BS Friday from Phoenix. Good to see you, George. Had breakfast with George a couple weeks ago. All right. Connor Malloy from YouTube says, Chris Magwood is a legend, and the Beam tool by Builders for Climate Action is a powerful gift to every professional builder, designer, and homeowner. 100% agree. And then, Mark,
thank you, Connor.
Yeah, right?
Take that question, Mark.
All right. So Mr. Mateo says, do we look at carbon footprint as a function of time? Is it better to build a 100-year home with a small footprint or a larger footprint for a 500-year home? This is an interesting one, Chris.
Yeah, I think it depends, what state do you think the climate is in? If we have 100 years to get this under control, then doing it in 100 years is good. If we have 500 years, then you could build a longer house. I think the science is certainly pointing to the fact that what we actually have is a decade or two to fix it. And so I think a lot of our assumptions about that kind of like, well, I'll invest in these carbon emissions now, but it's going to last for 500 years. If we're not on a habitable planet after 50 of those years, maybe that wasn't such a good investment. So, I think this came up in a session I was doing the other day. Somebody asked the question of like, I'm looking at two different cladding options. One of them has a high carbon footprint, but it lasts a long time. And the other one has a lower carbon footprint and it doesn't last as long. What do I do? And, my take on that is actually, if we're going to fix this in the next 10 years, you got to take the low carbon option now. And it may be that in 20 years when that material needs replacing, the longer lasting one is now a low carbon option. But, really, everything is pointing to the fact that we don't have a lot of time. And, this is by no means me saying, well, let's just build crap that falls down in 20 years. But you can build well with materials that have a slightly shorter lifespan. Like, I'm not advocating for a 2-year cladding, but a 20, 30, 40-year cladding with a low carbon footprint is way better for the climate than the 100-year cladding with a massive carbon footprint today. So I think time is critical now, and that was a great question for pointing that out.
Yeah, I appreciate it. Mark, you look like you were going to say something, then I threw a question in front of him.
Well, I think I don't know if everyone's picked up on it. I listen to a lot of folks talk. A lot of folks that have the type of knowledge and experience that Chris has talk in a language that doesn't land. And so you didn't bring up the points of this by using acronyms. You went right to the words first. And so there was no roadblock, there was no hurdle for the listening of what you're saying. And I have to say, the tech behind this obviously is big time, right? Not everyone can get to the level of producing that software, but your delivery and the application to make this conversation intuitive and quick choices of, like, you didn't say EPDs, you said environmental product declaration. You didn't say LCA, you said the life cycle analysis. And even if each of those words together are foreign, how you delivered it was dot, 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 right? Like graham crackers, chocolate, and marshmallows. Eat it up, right? You didn't go right to s'mores and have people try to figure out what it meant. It's brilliant. I really appreciate that.
Yeah, it's it's hard because I find that the deeper I get into this, you start to absorb all those acronyms and start talking that language. But
well, there's more of that coming up. Some other questions a little further down. We're going to have all kinds of conversation on EPDs. All right, let's talk. Does the carbon footprint of a building evolve? More tenants increase such? Question mark. Any adjustments required as materials age and deteriorate? That's a great question.
Yeah. So, when you look at the life cycle assessment of a product, it's broken into phases. So, BEAM is looking at, like, what did it take to get the material to my site? So that's they call it the product phase. It's the upfront part. And then there's a whole other phase of like the use phase. So maintenance of that material, fixing it, replacing it, that's another phase. And then there's end of life, which is, okay, I've taken it down, or it's going away, and what are the emissions associated with that? So BEAM is trying to inform people about that upfront piece, and that's the reason we concentrate on that, is because it's huge. Like, for most building materials, that's 80% of the full life cycle emissions happen when the thing is made. But yeah, there are important, steps along the way, and that's, at this point, in the world of the builders who already know that stuff. Like, when you're telling somebody, hey, I could give you cladding A or cladding B. Cladding A is like, it's what you want because it looks right, but it's more expensive, and it's this and it's that, and it lasts longer or shorter, and then you compare it to the other one. And I feel like, once you see the carbon numbers in BEAM, that's just one more piece of that information that you put into that decision-making process. Like, you may decide that, hey, these two things aren't that different in their carbon footprint, but this one does last a lot longer, so I'll go for that one. Or, like the example I just gave, you might decide, well, there's such a big difference in the carbon footprint that I am going to go for the shorter lived one because, that's the impact that I want to make today. So yeah, good question. There are all of those life cycle impacts across the whole lifespan of a product. But what BEAM is really focused on is that big piece that happens, before the material actually becomes part of your building.
If we trace back our footsteps a bit, there was a colossal thing that happened with the wood market of no added urea formaldehydes into our plywoods and our cabinetry and our engineered floorings. And then there was another one in the paint and the sealants market of no or low VOCs, and those became topical. So the early adopters of it brought it to the marketing, brought it to the consumers. The consumers wanted that of the other companies, and it was mainstream. And so I think the fact that none of those days did we even have a tool, right? We just had kind of California saying no, and then everyone else saying, what do we do? And so there was an evolution and innovation. So I think this tool is an asset, and I'm excited for the folks that they take that example that Dave said, and they just share it, and you tag and you share. That's your duty to say there's a better tool involved. There is a tool. I'm going to share it with everyone on the list that I know.
So let's we're at about almost 40 after almost in a few minutes. We got a ton of questions popping up here. This is awesome for you, Chris, because there are people seriously interested in this. We got some that are asking some tough questions, others asking how they can use it. So let's kind of pick through these. We want to make sure we answer everybody's questions. And we actually had some other documents that we want to share with you real quick as well. So lots to cover, and we want to make sure people that set aside that 45 minutes of time get what they came for. So Henry Mickelberg, don't get me wrong. There's a follow-up question to this once, or a comment. Using component EPDs as a methodology is a good thing when it comes to cumulative value, but they don't tend to take into account the holistic nature of using non-EPD holistic design like Passive House, which doesn't figure EPD metrics. And then he had to qualify my previous question. This is a short-term embodied energy versus OPEX content.
Yeah. I think, my first reaction to that is to say, what we're talking about is the carbon footprint of our buildings. And there are two parts to that. There's the part that comes from the materials, and there's the part that comes from operating the building. We currently need two different tools to do that. So, yes, there's the, Passive House software. There's all kinds of energy modeling softwares, and they're great because they tell you this piece of information. Now we have Beam that tells you this piece of information. And what we really need the community to do is go, and now we put these two things together and we see, like, what do we do? Like, and they're not in opposition to each other. I think there's sort of notion that, I either have to pursue, radical energy efficiency or radical low embodied carbon, but those are opposite poles. But, all the actual studies that we've done show that you can do both. Like, they're not mutually exclusive. You can actually make an incredibly, like, Passive House or better, performing building with really low embodied carbon materials, and you got the win-win. And you can also make a really poorly performing building with really high embodied carbon materials and do the lose-lose. Or you could be doing the lose-win, where it's like, it's a Passive House building, so its operating emissions are almost nil, but I had a massive carbon footprint up front, or, vice versa. So, like, I think what we want to do is not say, well, this or that, or this is the cumulative carbon footprint of our building, right. And we want to know and understand both of those things so that we get the win-win. And I think that's what the climate needs us to do, is like the win-win on both sides. So I don't see them as oppositional. Yeah.
Amen. And the Passive House and those other groups, those are still voluntary certifications, whether you're going for certification or you're just following the principles, and they're in relation to the energy. But most of those consumers already are following that path. And now those folks, including all the folks that will never hear about Passive House, right? The 95% of people that will never hear about them, now they have a choice for every product that they know of, and the products that they never heard of, right? And if you make the choice to have a sugar-filled, non-energy driven nutritional column, then your neighbor has the right to say, I'm over here being fit. Would you like to learn how? Love it. All
right, we got one of our favorites back. Haven't seen in a while. Bronwyn Barry has a question. All right. This is a long one here. Thanks for doing this, Chris. Wondering if you looked at including PV embodied carbon in your studies. From our early studies with pH Ribbon, our calculator plugin for Passive House PHPP, we saw PV as a higher upfront carbon than concrete in some homes. This changes the discussion on insulation. Can you give a comment?
Wow. Yes. Yeah, this is something we thought about a lot, because we did think about whether to include, a category for PV in Beam, but we decided not to. And I think there's a really important reason for, not that we don't care that PV has a carbon footprint, but I'm really cognizant of trying to make these apples to apples comparisons. And the thing is, if I'm going to calculate the carbon footprint of the PV that I'm putting on a house, I also should be calculating the carbon footprint of the entire electrical grid or the gas grid, if those are the two options I'm weighing. So, just because I stick PV on the house, like, suddenly, like, I want to count its carbon footprint and sort of like apply it to the house, but I'm giving every other energy option a free ride, because I'm saying, well, there's no carbon footprint associated with any other energy system, which is like completely not true. If we looked at what it takes to build a natural gas system and then accounted for all the leakage and all of that kind of stuff, that would also have a really high carbon footprint, and we're not. So I feel like we do want to know the carbon footprint of the PV, and I think it's really valuable to look at the embodied carbon and why are you putting PV on the building? Like here where I live in Ontario, I put PV on my building, but honestly, I'm offsetting electricity from a pretty clean grid. And so in that case, the carbon footprint of putting that PV on has a much longer payback time because I'm not actually reducing grid carbon emissions because of it. If I was in the province next door where, there's a lot more grid emissions and putting PV on the roof is like literally offsetting tons of emissions because now that grid doesn't have to supply my building with electricity, I would pay off those PV, upfront carbon emissions a lot faster. So I think the PV footprint belongs more in like the operational discussion in terms of like, is this the right thing to do operationally? And the carbon footprint then is like a salient point of that. But I wouldn't just like add the carbon footprint of PV to my house if I'm not adding any of the other energy infrastructure.
You did comment really clearly. That's the personal choice. That's the regional choice. And you're using the information and data to make that choice. And Bronwyn's added comment there was, you don't have that choice in California. You must have a percentage of solar. And so when it comes to that, hey, maybe there will be a really large sponsor that comes out and helps with the data of all the other energy sources, from ground source to air source to renewables to fossil fuels.
Yeah. So we're going to do one more question, then I want to show the other resources, Chris, and then Chris, I know there's more. The comments are just flying in. So Chris, you're going to have to. We'll be here all day, and Mark's a busy guy. No, but we'll make sure that Chris goes and answers everybody's question. There's questions about what materials they can use for their building and so on and so forth. So I think it's a good way for
go to the calculator. It's there.
Yeah. So, but here's a good question I thought from Dan Rappel from YouTube. How hard do you think using this tool for a relatively small institutional builder will be? It will house a transit station, library, and offices, 3,200 square meters total, 3 floors.
That's a good question. I think Beam is appropriate for a building of that size and scale. We ended up making Beam because a lot of the existing tools are particularly focused on really large buildings and don't kind of include any of the really typical assemblies and materials that do end up in smaller buildings. So I would say, by the time you get to large concrete or steel frame type buildings where there's, that kind of skeleton structure that you're then sticking an envelope on, the tools for bigger buildings are better. But we've certainly seen people using Beam for like 10,000 square foot buildings, kind of like, 5 stories and under. You can sort of, there's a lot of options for concrete and steel in Beam. So I think as long as the building's not too big or too complex, that Beam is a completely adequate tool. So from the short description there, I think you could definitely model a building like that in Beam.
Yeah,
it's nice. Sure. Dan's been a longtime Crusader. He's in Chicagoland. Incredible guy. Great team.
For sure. And just a quick shout out, because I like to, this is somebody that made that question about the cladding materials. And Chris, maybe you can answer that offline and show them where to find it. But Edgar Dearden, appreciate you tuning in today, and wanted to make sure we gave you a quick hello. All right. So, Chris, what haven't we talked about? I know we had 2 documents in here. Let me go back to my stop sharing and reshare screen. But why don't we touch on these 2 documents and where people can find these resources if they're available to them? And then we'll wrap it up from there. How's that sound? Good?
That sounds great. Yeah.
All right. Here we go. Emissions of materials benchmark assessment. So what is this all about?
So this is a study that we just finished up for the Toronto region. It's the biggest benchmarking study of its kind in the world. So we looked, we actually modeled over 500 houses that have been built in that region in the last year or two. So it's a pretty big study of a pretty large group of buildings, and it starts to feel like that we're getting towards understanding what an average, what the carbon footprint of an average house looks like, which is kind of between 150 to 200 kilograms of emissions per square meter of area. But also, like, what does that look like in a whole region? In the Toronto region, it's like almost a million tons of emissions every year from building small residential buildings, and the municipalities are like, really, like that's more than our landfills emit, and so it's a great study. It goes into which materials contribute the most, how you can go about abating them. It's a pretty in-depth study, and like I said, sort of the biggest one of its kind. So it starts to feel like, okay, we're starting to really understand a picture of what this looks like for buildings at this size and scale.
Yeah,
I was on a webinar, Chris, yesterday, and I was exploding with comments because there was a very influential person speaking. And they kept using a tagline that I hadn't heard before, and they kept saying, "Demolish or die, demolish or die." And I was sitting there, I was like, "Would you please come and listen to Chris tomorrow? Like, are you really making the claim we need to destroy buildings right now, or we're gonna die? Like, don't say that."
Takes all types, Mark. You know what it's like out here in the social media world. We get beat up for nothing.
That's like saying chocolate is bad. Like, don't use those kind of statements in life.
Yeah, chocolate is not bad. Go ahead. What do we got here? This is the other benchmark, and then
tell
us where we can find all this.
Sure. This is a study that we did for Nelson and Castlegar in British Columbia. And same thing, it was as-built houses. So, they're real examples of homes being built there. But what was great about this study was we also had the energy models for those homes. So we were able to do that thing we were talking about earlier of like, what does it look like when you put the operational and the embodied beside each other? And, at the highest level, the really interesting thing about that report was it showed that there is no direct correlation between the two. We had examples of houses at the best level of energy efficiency with really low embodied carbon. We had really efficient houses with really high embodied carbon. We had inefficient houses with high and low, like everything. It was all, one was not the predictor of the other. And so I think, that this study really makes it clear that it's, what we're looking for is the win-win, and the win-win is possible, but also that in a lot of cases we're doing the lose-lose, and we definitely want to, get away from that. And so it was really great to have a study where we were able to look at real buildings in a real place today, and see both of those
and
aspects.
Find that there's not a correlation. I mean, I wouldn't have guessed that.
No, me neither. Nope.
And there's a lot of graphs and data in here as well for those people that love spreadsheets and data.
Yeah.
Just so everybody understands. I mean, there's a lot of information in both of these documents.
And the document is online. You don't have to print the internet.
That's right. Yeah. So all of those things, plus a few other studies we've done, are all at the buildersforclimateaction.org website. Same place people would go to find BEAM. So.
Yep, and it's also being put in the comments right now. So you can just look in your comment sections. You'll find links to find all of that on YouTube, Twitch, Twitter, you name it. We're putting it out there. So
how long did it take to pull together all that? Just a short answer on those 500 homes, Chris. And then how long will it take our community to do the next 500 new construction buildings, right? And the next 500?
Yeah, it depends. When we do a study, we're starting from somebody else's plans that we've never seen or worked with, and often in PDF form. So for us, when we do a study, it's a bit of work because we're just having to find all the numbers to put into BEAM. If you have your own design software and you can just say how much, what's my exterior square footage, boom, you could just put that number in. So, but typically it's like, if you have the dimensions at hand, it takes somewhere between an hour to maybe an hour and a half to run a house through BEAM. So it's not big, and it's like any tool. The more you work with it, the faster you get at it. So it's definitely like your first time through, you might end up spending 3 or 4 hours on a model. But once you get the hang of it, yeah, about an hour a model is a pretty reasonable expectation.
Like building a house. It's like
Yeah.
building a house. Who out there's built a house and got it all done real quick the first time around?
No, the second time was easier.
No, it's always the third time, Mark. It's always the third time. I know it. Anything new takes a little bit of practice and time, and it confuses the daylights out of you. But once you get it and it starts clicking, that's where the value of the resource comes into play.
Yeah.
The level though, you pointed to a rub, and I call the rub as the things that are a stopping point. And I don't understand why we don't have grids on plan sets of the PDF nature that shows the cubic volume, that shows the surface area of the wall. Why are 7 to 70 people calculating that again and again when it was a click and a click and a click? Now, the folks that we do know do include that, and that's great. So find examples, eliminate the rub for others. What are you doing to support the next person?
Yeah, and that's something, that's definitely the next evolution for Beam, is to start being able to integrate with some of those other software tools. Like, hey, I'm already making an energy model. I've already figured out all of this square footage and area and stuff like that. Like, can it just plop in? Well, yes, it can. And that'll be what we work on next. And I think, that's when we ask people for support when you go and download Beam, like that's where that money's going to go, is like, how do we tie this into ResNet? How do we tie this into PHPP? How do we, tie it into some of the sort of leading design softwares? I think that's
Revit,
the next
Wolfie
real
passive, everything. Yeah.
Cool.
A shout out real quick there, Connor, is I think today or tomorrow is the final time to enter your wallassembly.com. And Chris, your program and your support for wallassembly.com has been incredible. So shout out to all those folks, Dylan, Matt, all those wonderful people.
That's right. And listen, everybody, if you're not following Chris Magwood and Builders for Climate Action, you're wrong. You need to go follow those guys and gals and figure out what they're doing and follow in their footsteps, because they're doing it right. Use the free tool, share the free tool. Make sure you help spread the word. He's put a lot of time into this, and I'm sure it wasn't just him, but several other people. Help them get the word out so other people start using it. And also, we'll be back tomorrow morning. Coffee with Dave. Mark Barenaked Willie's supposed to attend that one with me tomorrow, so we'll see if he can still wake up. Sometimes he likes to sleep, this guy. You got to watch out for him. He has late nights. He's a wild guy. Check out, he's got the ZZ Top beard and everything. You got to watch out for him.
It's been years since this kid has had a long night. I mean, the morning pops up and we got work to do, brother.
We do got work to do. And put on your calendars for next week. We got the A-listers coming on. We have a program. It's going to be called Killer House. And that is right. Shemaine Nugent, Ted Nugent's wife, is going to be on the show talking about her documentary and her new book release that's going to be coming out as well in a few months. You don't want to miss this. They're really putting a lot of effort to it. And it comes, and I say this all the time, it almost killed her. Her house and the black mold almost killed her. And this is where people's passions typically come from when it comes to this. Houses can make you very sick, and this is what this is all about, and we need to start educating the world on it.
That's a cue to go to Beam and learn about those natural materials and how your wall assembly works, right? The information is out there, folks. It's right there.
And make sure you subscribe to our YouTube channel. We are growing. It's amazing. We're getting hundreds and hundreds of new followers. We're going to start doing some more special stuff on our YouTube channel as well. Hit that like and subscribe button, because it will notify you every time Mark and I go live. That way you don't miss our shows.
The reason it's growing is because of these topics and because of the continued potential for transformation with the innovation of this and other things, right? So very inclusive. So there you go. Brownwood's gonna help bring it into their thing. That's a public declaration from someone that knows Chris very well. Yep. And that's our role, folks, to share it. You might only know 2 people. That's great. Right. Those 2 people, they want to know the nutritional facts. So get them this link.
That's right. Use our show to network and grow your business and grow your knowledge. That's what it is all about. All right, listen, that's a wrap, everybody. We got some cool stuff Also coming up next week, guess what, Mark? We're going to have CertainTeed on the show this Monday. We're going to talk about what they're working on in their innovative labs. And maybe, Chris, they'll have something that can fall within what you're doing, because they are looking at some of this stuff. It'll be interesting. So we are going to have CertainTeed on Monday. And then guess what, Mark? We're talking about stainless steel buildings Wednesday on our product spotlight. That's right. Entire buildings made out of stainless steel, multi-story, 4, 10, 15 stories, no concrete. It's a pretty amazing thing. It's lightweight. You haven't seen this one yet. And guess what? They can produce over 100,000 square feet of building a day out of their factory overseas.
Let's get these two folks to sponsor the beam calculator. Let's get that in there. Beautiful.
That's right. When you go to this beam calculator, one last time, do not skip over the donate part. Help out. It takes everybody, and we're making moves. So, all right, Chris, thanks again, man. Appreciate you. Don't go anywhere. We'll come back to you after the outro. Mark, always a pleasure. We will see you bright and early with your coffee. And for the rest of you out there, thanks so much for the support. We really do appreciate each and every one of you, whether you're watching us live or on the weekends in the evening. So, all right, Mark, that's a wrap. We'll see you guys. Bye now.